Hi everyone, welcome to CSM 61A, Week 8, Question 2. So in this question, this is pretty similar to those what would Python display questions, except now we're dealing with a function called foo. So let's first take a look at what we have inside of this function. So our function header defines the function to be foo, and then inside of the function, we set a variable a equal to 0, and then we have an if statement with a couple of prints and a yield statement. So our job is to go through these lines of code and determine what Python would output. Okay, so let's start with this first line here, which is just to determine the output of this call to foo. So because we have the open parentheses, we know that this here is a call to foo. And whenever a function that returns a generator is called, it will simply return a generator object. So that can be written as such. Now it's important to note here that what we're doing when we make our initial call to foo is simply return a generator object, but we have not started going through this iterator yet. And that's because we don't start going through an iterator until we actually call next. In this case, all we've done is call a generator function, and so we will return a generator object. Now in this next line, we set foo gen equal to foo. And again, this is a call on foo. So what will foo generator be? It will just be a generator object, right? So just to be clear, this is also a generator object right here. So we know that we have a generator object in foogen, and now we call next on the foo generator. So what will next call? Let's take a look inside of our function. So we start by setting a equal to 0, and then we enter this if statement, if a equals 0, because this is true, since a is in fact equal to 0. Next, we'll print hello. So since we're trying to determine the output, we know that first we can print hello. Then we reach our yield statement, which is just to yield a, which is 0. So what happened here? When we call next on an iterator, we will keep going until we get down to our first yield statement. So we followed all of our lines of code until we hit this yield A. Once we hit that yield A, then we know to finish for this next call. And then we will pick up where we left off the next time next is called. So we call next yet again in the next line of code. And so we have to pick up from where we once were. So we just yielded A, and now we're here at this line. So we will print world, and then that is actually the end of our function, because there's no way to move back up since there's no loop here. We finish this last line, and that's it. That's the last line. So we're done. So in this case, because we've called next and there's nothing to iterate over, we will actually return a stock iteration error. Because again, there's nothing more to yield. When we are dealing with a generator function, then what we do is we keep going until we hit a yield statement. We pick up from where we left off, and so on and so forth until there's nothing more to yield, in which case we return a stop iteration error. Okay, on to the next part, we have a loop. So for I in foo, we will print I. When we loop through something like this, we will essentially loop through every single element. So for I in foo, let's first go through foo. We start by calling foo again, so this entire function is now reset. So we start back from the top where a is set equal to 0. So we know a is equal to 0, therefore we will enter the if statement, if a equals 0, and then we will hit print hello. We will yield 0, then we will print world, and that is it. So again, when we have a loop like this, we just want to print out every single element in our generator function. And we did that by stepping through each line of code until we were finished. And in this case, that only yielded one value in addition to these two print statements. Okay. Next, we have a variable a, and we set it equal to this big chunk of code. So to start, let's just dissect this big chunk of code by starting with this map function. So what the map function will do is just give us a sequence of numbers that after applying this first function to the range of 10. So I'll draw the map up here. For every number between 0 and 9 inclusive, we will call lambda x minus 1. So to start, we'll start with 0, and we'll call 0 minus 1 to give us negative 1. Then we'll go on to 1, because we're going from every number in the sequence between 0 and 9, and just subtracting 1. So we'll have 1, 0, 1, 2, and so on. That is what the map function is doing. Then we call lambda x x mod 2 in our filter function. So our filter function will now have this newly drawn map array as one of its arguments, and this lambda function as its other argument. So it will filter out any element in our list where it does not evaluate to true. So x mod 2 will evaluate to true in any case where x mod 2 is not equal to 0. And if x mod 2 is not equal to 0, then what does that imply? That implies that x is odd. Because if x is odd, then x mod 2 must be equal to 1. Otherwise, it must be equal to 0 because there would be no remainder left when x is divided by 2. So what this filter function is essentially doing is just taking this right here and filtering out any even values to leave us with only the odd values, because the odd values will return true when applied to our filter function. And then finally, we set a to be the iterator over this list. So our actual iteration will look something like this. -1, 1, 3, 5, and 7. And again, we got that by just stepping through first the map, then the filter. So now let's actually get into what this will output. So we call next on A. Okay, let's just look at our sequence, and we see that the first value is -1. So we can kind of get rid of this -1 now because we've already called next on it. And so what we do in A is we just move on to the next value, as we've seen with iterators. So here we now have the reduce function, and inside of reduce, we have a lambda function followed by A as our two arguments. So let's remember what the reduce function does. A reduce function will go through an iterator piece by piece and just call the function on two elements. So it'll first call the function on 1 and 3, then it'll do so on whatever this returns and 5, and then whatever that returns and 7. And in this case, our lambda function is just the addition function, right? We take in x and y, and we return x plus y. So reduce will just be 1 plus 3, whatever that is, plus 5, whatever that is, plus 7, which is really just equal to 1 plus 3 plus 5 plus 7, which is equal to 16. So that will be our final output. I'll just erase this to clean it up. 16. And that is it for this question.